Hello and welcome to today's lesson on the uses and dangers of EM radiation. Our learning objectives are to describe the uses of waves in the different regions of the electromagnetic spectrum and also to describe which waves are dangerous and why. Okay, so now we're going to see what happens if I take a light bulb and I place it inside a microwave. Now, to keep things safe, I'm first of all wearing safety goggles. I'm also taking the light bulb and placing it in a beaker full of water, and this water stops the microwaves from getting to that metal part at the bottom because obviously, as you know, putting metal in a microwave causes problems. Now finally, I'm going to limit the time to just 15 seconds to make sure that nothing overheats and explodes. I will just say please don't try this at home because it's very easy to get it wrong and cause damage to your microwave. Right, let's see what happens. Wow, there you go, you can see the light bulb itself has lit up in the microwave. I'm going to stop this now before it overheats. Light bulbs normally work using electric current flowing through the tungsten filament to cause the filament to heat up and glow brightly. A microwave oven normally works by having microwaves fired into the food and then they are absorbed by the water molecules in the food. In this case, we put the light bulb in the microwave oven and the filament was absorbing those microwaves, causing it to heat up and glow brightly. We're now going to look at some other uses for electromagnetic waves, starting with radio waves. Radio waves are used for broadcasting, communication and satellite transmissions. In your books, write down a title of uses of radio waves and then underneath these three uses. You might need to pause the video while you get it copied down. Next up we have microwaves. We've already seen how microwave ovens can be used for cooking to heat up food and light bulbs, but they're also used for communications. Microwaves are used in mobile phones and they're also used for satellite transmissions. Pause the video now while you write down the uses of microwaves and these three things. Try and remember that mobile phones use microwaves rather than radio waves. People often get the two confused. Now we'll move on to the uses of infrared light. Infrared has a number of uses, including infrared photography. Here we have an image of a stealth fighter, which is normally invisible to radar and extremely hard to see at night because of its black colour scheme. But if you use an infrared camera, you can pick it out reasonably easily because of its incredibly hot engine. Pause the video here and write down a title of uses of infrared. Heat radiates as infrared light, and so we can use infrared as a way to cook food. Make sure you write this down under your title of uses of infrared. Thermal imaging is used in a wide variety of roles by both the police, the fire service and the military. Pause the video now and make sure you add thermal imaging to your list of uses for infrared radiation. Here you can see an infrared camera that's mounted on a police helicopter. They find this very useful for pursuits when they are tracking criminals because the infrared camera can often see through things that visible light will not penetrate. Infrared can be used for short-range communication. For example, TV remote controls use infrared diodes to send signals to control the television. Now normally we can't see these, but if you hold your TV remote control up in front of some digital cameras, they can actually detect it and you'll see it glowing on the digital screen in a way that you can't see in real life. Pause the video here while you write down the fact that infrared light can be used for communication. Infrared light can also be used for fibre optics, for things like telephone and internet communication. Make sure you add this to your list of uses of infrared light. You're probably very familiar with the use of visible light for things like photography and of course our own vision, but it's also used for things like data storage and communication. Pause the video now while you add the uses of visible light to your list. You might be wondering how we use visible light to store data. Well, CDs, DVDs and Blu-ray all use a visible light laser to read the disc. And we can use flashing lights using Morse code to communicate, particularly between ships. Now we're going to look at the uses of the ultraviolet part of the electromagnetic spectrum. And this here is an image of our sun as it would look if we were able to see it using ultraviolet light. Ultraviolet light has quite a wide variety of uses. It can be used for security markings, detecting forged banknotes. It helps our bodies produce vitamin D. It can also be used to disinfect water, and at crime scenes it's sometimes used to detect bodily fluids. Pause the video here and copy down these into your book. So how can ultraviolet light help us detect forged banknotes, or for that matter, any forged document? Passports, banknotes and other important documents have a special kind of ink which is normally invisible. But if you shine an ultraviolet light over a valid passport or banknote, then the special markings in that ink will glow, allowing you to identify that it is indeed a valid banknote or passport. Our skin absorbs ultraviolet light from the sun, and this allows it to produce vitamin D. In the winter months, sometimes people don't get enough sun, and as a result they can suffer from vitamin D deficiency. Now you'll learn later how ultraviolet light can be dangerous, but we can use that to our advantage by using it to purify water by killing bacteria. Some of you may have seen already fish tanks which have ultraviolet lights above them in order to keep the fish tank healthy. The police often use ultraviolet light at crime scenes in order to identify bodily fluids. Next we're going to look at some of the uses for X-rays. Don't forget to write down the uses of X-rays and pause the video as we go through. X-rays can be used for security scans of both people and their objects. You've probably experienced this at an airport. X-rays have enough energy to pass through flesh, but they are stopped by bone. As a result, they can cast an X-ray shadow on a detector. The denser bone, or metal, are more effective at blocking X-rays and will show up as white, whereas the muscle and tissue are less effective and so will show up darker. Here we have an X-ray showing not only the patient's bones but also metal pins and even their fillings in their teeth. Now we're going to look at some uses for gamma rays. Gamma rays can be very dangerous, but this means we can use them for sterilising things like food or medical equipment. We can also use them for the detection and treatment of cancer. Please pause the video now and add the final set of uses for gamma rays to your books. Gamma rays pass through food and will kill any of the bacteria that's still alive on the food, thus allowing it to survive longer before it goes off. The same principles used for sterilising medical equipment. New medical equipment is packaged in a sealed airtight container and then bombarded with gamma radiation to kill any bacteria inside. Gamma rays can also be used to detect and kill cancer, which is something that we're going to investigate in a lot more detail in the topic of radiation. We make extensive use of radio waves, microwaves, infrared and visible light, but we're much more careful with how we use UV, X-rays and gamma rays. For example, we wouldn't use X-rays on a mobile phone, and there is a reason for that. Ultraviolet, X-rays and gamma rays are the highest energy rays. They're called ionizing radiation because they have enough energy to ionize atoms and change how they combine with molecules. This means that they can damage our DNA, which can lead to mutations and can kill cells. The woman you see here made extensive use of tanning beds when she was younger. By the age of 21, she'd developed skin cancer as a result of all the exposure to ultraviolet light. Make sure you record in your books that ultraviolet light is a form of ionizing radiation that can cause skin cancer. X-rays and gamma rays are even more powerful and more penetrating than ultraviolet light. As a result, they can cause cancer throughout our bodies. Right, now without checking back in your notes, try and see if you can answer all 10 of these questions. Pause the video now while you do that. And that brings us to the end of today's lesson. Thank you very much.